So now what are you seeing?
I am seeing a room with white walls and a blue ceiling. There's a eTechViral sign on the wall. In the center, there's a black camera on a tripod, positioned in front of a black two-seater couch. To the left, there's a coffee table with a glass top and a purple cup. On the right, there's a person sitting in a chair, but only their legs and feet are visible. There are also several green plants in the room. In the foreground, a laptop is open, displaying lines of code.
Assalamu alaikum everyone. My name is Muhammad Adnan and I'm a software engineer and co-founder at eTechViral. And in today's video, I'm going to show you how to build Project ASTRA clone in Flutter. If you don't know about Project ASTRA, let's learn about it together.
I'm here with the latest research prototype of Project ASTRA, and we're going to see how it can help me fix my bike. Hey, go online and look for a user's manual for a Huffy mountain bike.
I have found a user manual for you. What would you like to know about it?
Okay, cool. Now scroll until you find the section about the brakes.
Sure thing. Looking for that page now.
I think I stripped this screw. Can you go on YouTube and find a video for how to fix that?
Of course. I'm opening YouTube now. This looks like a good video.
Place a rubber band over the head of the screw.
Oh, nice.
Press down
Nice.
firmly.
Can you go through my emails with the bike shop and find which size hex nut I need?
Sure. According to the email from Bicycle Habitat, you need a 3/8" hex nut for your sprocket. I've highlighted the correct bin for you.
It seems like I need a spare tension screw. Can you call the nearest bike shop and see what they have in stock?
Yep. Calling them now. I'll get back to you with what they have in stock.
I think my brake pads are wearing down. Can you check the manual again and see if it talks about them anywhere?
According to the manual, if you look on page
Hey.
24,
Do you want to get lunch?
Yeah, give me 5 minutes. Can you finish what you were saying?
as I was saying, if you look on page 24, section 2, you'll see how to replace the brake pads.
Hey, any updates on that call?
Yep, I just got off of the bike shop. They confirmed they have your tension screw in stock. Would you like me to place a pickup order?
Could you show me some examples of dog baskets I can put on my bike?
Sure, I can help you with that. Just give me a moment. Here are some options. I think Zuka would look really great in these.
So that was the real Project ASTRA. Now to bring similar experience to Flutter, you have to understand few things. First of all, we will understand the difference between a legacy voice bot and a human-like voice bot. So what you are seeing on the screen, we have two flows, a legacy voice bot flow and human-like voice bot flow. First of all, what happens in the legacy voice bot flow? What happens in here is we speak through microphone, converting that speech to text and providing that text to the generative model. What happens in generative model is it processes the text and return us the response, and we convert that text response from text to speech and going for playing that. So that was a long round trip that happens in the legacy voice bot. But in the contrary of this, we have the human-like voice bot. In the human-like voice bot, we receive a raw data directly from the microphone, that is PCM16 pulse code modulation data. What happens in here, once we receive this data, we're streaming it directly through WebSocket to the Gemini Live API server, and that server returns the response in real time. And as we are receiving that response, we are directly playing these chunks receiving from Gemini Live API, and that makes a real-time low latency voice bot experience. That's why we call it a human-like voice bot. So that was the core difference between a legacy voice bot and a human-like voice bot. So we learned about Project ASTRA and we understood the difference between a legacy voice bot and a human-like voice bot. Now, what is that core thing that enables us to build such human-like experiences? So that is what called Gemini Live API, or if you are working with OpenAI, so here is GPT Voice API. So the Gemini Live API enables us low latency voice and video interaction with Gemini. And there are many other things that you can explore with Gemini Live API or building agentic application. So basically there are two ways to build Project ASTRA clone in Flutter, or you can say using its capabilities like video or audio modalities. The first one is you either use Google GenAI library or Firebase AI logic, but there are their own pros and cons going with these two options. There might be other options, but these two are the efficient and the easiest ones. So I will tell you, going with the first option, what happens actually in here. Using Google GenAI library, you have to configure a Python environment, and then you have to write some code, create an endpoint that would be considered as your backend server. And then you have to consume that WebSocket URL in your front end, and you will be manually dealing with WebSockets for sending data from front end to that backend, so that backend send that data to Gemini and return you the response in real time. And also you have to set up for video and for audio bytes too. So you have to write a minimal proxy server backend in the middle, going with the first option. And the beauty of this first option is you have to, like, there is no prohibition on a specific platform. Like if you write a backend in Python, you can integrate it with either with Android, iOS, or directly in Flutter. So there is no prohibition in going with the first option. But with the second option, the Firebase SDK, that has done everything under the hood, like dealing with the Google GenAI library and other things that it provides us and abstract the core functionality from us. So that is what Firebase has been doing, providing authentication, providing the hosting services, providing the serverless functions, and many other things, Crashlytics, analytics. But other than this, it also have integrated this Firebase AI Logic SDK, where we can create the chatbots, but it also have now the capability of consuming internally the Gemini Live API to build similar voice bot experiences. But it is not that mature yet. When I say that it's not yet mature, that I means that currently you can build a voice bot only for Android, and you can build it for Unity application and Flutter, but you cannot build it for the iOS or the web. The support for these platforms is coming soon, which means that if you are going with Flutter, you also will not be able to build similar experiences in iOS for iOS platform as you will be doing it for the Android. And same applies for the web. While doing building a voice bot using Gemini Live API with Firebase, you cannot build also for web, but you can only currently do for Android. And there is one more thing that you also have to keep in mind is currently in Firebase AI Logic SDK that is built in Firebase SDK, you cannot also like stream audio to the backend as you will be doing manually in our Python server. So this capability is also coming soon in Firebase SDK, and developers are constantly working on that. So once we have this SDK, so then we don't have to write anything manually, creating our manual server and then connecting it to Flutter frontend side. So everything will be done for us by the Firebase AI Logic SDK, and then we don't have to care about the creating our server as it said. So these are the two ways that you can go with, and I explained everything about it. And the one we will be going with currently to build the Project ASTRA clone, since Firebase don't have these capabilities of video and we cannot do it for iOS and we need it for cross-platform. So for now we will go for using the Google GenAI library instead of the Firebase AI Logic. So these were the things that I want you to understand theoretically before diving into the code. So now it's time to dive into backend code and understand how this backend code is operating, receiving data from frontend, sending data to the frontend, and how we are being able to build Project ASTRA clone in Flutter. Let's dive into the code. So we are back on the VS Code editor, where currently what you are seeing on the screen is a minimal Python written server where we used Fast API for building basic API structure, get post, but currently we don't have the get post API but a single WebSocket endpoint, and we used UVcorn for running that server locally. Okay, so let's go through this code. I will explain it bit by bit to you that what I have used to build this. So first of all, for building that, what I did, I create an empty directory, and I ran a command that you are seeing currently on the screen. You have to run that to initialize your Python environment for installing dependencies that you can see that I'm using in my main.py. Okay, once you have the Python environment, you have to also create a source directory. Inside that, you have to go with it's like what we are using the naming convention, like what are we using the naming convention for this. Like, let's create a main.py, or you can create app.py, whatever you like. So I have the main.py, and I also have the prompt.text that we will be picking a specific prompt that you want to give to our model, and based on that it will take decision like, okay, I will be doing this specific task. So currently I don't have anything, I keep it as general, but I will show you how you can like pick the prompt and then provide it to the model, and it will take a decision based on that, obviously. Okay, so in the main.py we are importing these packages: async.io for asynchronous operations, base64 and JSON obviously for the conversions, fast API. From fast API, import fast API so that we can create an endpoint from the app. You can see app fast API, and then from app the WebSocket, and our URL goes here, and the WebSocket and WebSocket disconnect for clearing their resources. Okay, next we have the Google Gemini that you have to install to enable us connecting with a live API so that we can talk to it, provide information about our audio and our video that we will be consuming from the camera package, and then we will be providing that to the model, and it will take decision based on that and will tell us what it's seeing on the camera, as you have seen in the Project ASTRA demo. So that is what we will be building. So next we have the OS to interact with the OS, like reading or writing the files. So we have this snippet of code which is defining the prompt path, like accessing the prompt.text that we have in here, and then opening that and then reading that simply, and we will be passing it to the model. Later you will see we are initializing the fast API, and we are getting the Google API key from the .env. I will not go for opening it because it's confidential, and to get the API key to use it in here, you can go to the Google AI Studio and simply tap this get API key, and next you can tap this create API key. You can select then a project from the Google Cloud Platform that you will be having any, and then once you select one, you can go for create API key in the existing project. Then you will have an API key that you can copy and paste in there. So once you have API key, you can store it in the .env file as I'm doing it, and then do these two steps, .env and load.env, and then simply do os get env and pass that API key, and that's it. We have API key in place. Next, what we are doing is we are creating a WebSocket endpoint. So why a WebSocket endpoint? As I explained earlier, we are not using any HTTP request and response, like receiving data from microphone, converting from speech to text, and the text, providing this text to the model. We are not doing that anymore. We are following an approach like receiving the raw data from the microphone PCM16 and then directly streaming it to the backend, and then it will the same way provide us the response in the stream, and then we will be playing it. That's it. And then what's next? We have an asynchronous div function for handling asynchronous task also, and here we are going for accepting the WebSocket so that the handshake has been instantiated, and now we are good to go for sending or receiving the data between our server, our frontend, and the Gemini live API. And first of all, for creating some states like it's now connecting or connected, I am simply sending a JSON in the WebSocket. That's it. Now providing the Google API key or the API key that we have received from Google AI Studio to the client. That's it. Now we are specifying the model. There are a lot of models in here that you can use. Currently I'm using the model of 2.5 Gemini Flash Preview Native Audio Dialog, and each model have its own capabilities that you can explore. Specifically this model that native audio dialog is for native audio processing that respond with more emotional tone or understanding, like how you're talking to it. So it understands these emotions and these tones of human, that whatever who is talking to that model. Next, we have a few line of codes of that config. We are configuring the Gemini Live API, like what all these things, like what it is going to hold. Basically, it has a modality of audio, like it will receive the response in audio and will return a response in audio. So that is what the modality means. Secondly, we have the real-time input config, like prefix padding milliseconds and silence, like silence duration millisecond. So by silence duration millisecond, it means like if you are not talking for 500 millisecond, it will consider that is the silence and I don't have to respond anymore. So that is what this configuration means. And here is the speech config. What we are doing here, we are defining a voice name. We are doing it for Lida, and Lida is a specific lady model that respond in like who is Lida, who prepared that voice for that. And we can select any other person voice, that can be anyone that you can find in the Gemini Live API docs. We are doing it Lida, it is lady voice. Okay. Secondly, we have the language code in US. We are defining the language here, and a system instruction. The system instruction is that we are receiving from that prompt.txt. Currently, I have not defined anything. You can write anything here in the text in any format. So that will be the identity of your model that you are providing it to. So once we have the configuration set, and this generation config is basically this top K, top P, and temperature is we are telling the model how specific you should be on what you are trained on. So this generation config is based on that. So next, here comes the important part. We are connecting to the Gemini Live API from the config and the model. We are calling that connect, and we are storing it to the session. Now here comes the important part. We are doing the send WebSocket send JSON. It is saying successfully connected. Okay. Once it is successfully connected, we will receive this response from frontend and will start everything, like sending the camera frames and the audio too. So asynchronous if send to Gemini. So send to Gemini means what we are receiving from our frontend Flutter application will directly be sent here to the send to Gemini. And then once we send this, we also have the method of receive from Gemini. So we are sending it to the Gemini and receiving them. So in the send to Gemini method, we are receiving from frontend and sending it to the Gemini. And in the response, what is returned by the Gemini Live API, we are also streaming or sending that in the live WebSocket to the frontend to take the action based on what data we have received. Like if we have received the bytes, we have to play them. If we have received the turn completed, so which means that you have to stop. You have to flush the audio playbacks, like bot don't have to talk anymore, turn is completed, or also in case of interrupted. So it also have the capability of interrupted in that our human like voice bot. So now let's go through it step by step. Here you can see the type WebSocket receive. So what we are receiving in here from the WebSocket, bytes and text. So here I will tell you two things about WebSocket. We can receive two types of data in WebSocket, that is either JSON or bytes. So in the first, that is bytes, we receive the bytes from what is captured from the microphone and that we have sent in here. And then we are calling send from the session send real-time input audio types blob and the binary message with the audio PCM rate 16,000, the 16,000 sample rate. Okay, we are sending this data coming from front end, this backend is sending the bytes to the Gemini Live API. So that is what happened in this snippet of code. Next, we have the text. Text is basically a JSON. You will see we will do a load.json on here, and then we will be sending specific type of image input, image data that will also be in the base64 encoded. That's why we have imported the base64 in here. And once we have the frame you have to remember one thing in here. We will be sending the camera frames every second along with the audio chunks that we will be sending. So these will be in the real-time streaming to the Gemini Live API, and in the stream we will be receiving that response in the audio, that what this model understood about the specific image along with that we have sent along with the audio. For example, point a camera to any object, like in front of, I have the laptop, and I ask, hey, what is currently on my screen? It tells me there is a laptop and some code inside. So this is what is going to happen in this scenario. And other scenarios are like stream ended to tell the voice bot that now you have to stop. That's it. And the other except else are simply handling the exceptions of when disconnected, any warning, or simple WebSocket disconnection, or any general exception if received. That's it. Next, we have the receive Gemini API response. So what we are receiving from Gemini if we interrupt. So the interruption here means is whenever bot is speaking, from the speaker's voice is coming out and we speak through it. So that is automatically analyzed by the WAD that is configured in the backend of the Gemini Live API. WAD is basically voice activity detection. It is detecting the voice activity during voice bot playback, so it is considered that response as interrupted, so it automatically sends us this interrupted message, so that based on that we take the decision to flush the audio. That's it. Now we have once we receive the interrupted, we send this to our frontend to take the action based on that. Next, for the turn complete, we are doing the same, and for the WebSocket disconnection, exception, and these are the other methods for configuring that. So these two methods are very important: send to Gemini and receive from the Gemini. So these were that was our minimal backend receiving the audio and image from the camera one by one, and then sending it to Gemini Live API, and it will only return us the audio so that we can play it in our front end to build Project ASTRA clone in Flutter, or you can say using similar capabilities to build any other specific project. So we had a very detailed walkthrough in our backend, that what is going to happen in our backend and what our front end is going to receive. So now we have to walk through the Project ASTRA clone that I have created. I will not go at a very basic level, since you have to have some knowledge about Flutter and building a basic application. So I will be just showing you the core points of how to receive that data through WebSocket and recording that and playing that back, and every important step taken through also camera for sending the data to the backend that we have created. So now let's have a walkthrough of our front-end code, and then we will go for running our backend locally and then running our Flutter application to see how our Project ASTRA works. So now I am in my Flutter project named Project ASTRA Flutter. We have starting from the assets, we have two images currently. That is the background that I'm using on the landing page, the initial page that we'll be landing on when application runs. We have colors, we have specific constants, and in that constant I am setting up currently for a local server, and I also did once with deploying that backend on a render web service, but it was a little bit slow having 512 MB RAM. I kept it currently on a local server. So we'll be doing on the local server, we have to run our backend locally, and then using SAM network in our phone and in our laptop, so that it will be able to connect seamlessly with that WebSocket and we'll be able to talk with our bot. That's it. Secondly, we have the home page. So what is in the home page? First, let's start from the main.dart story. In the main.dart, we have nothing, providing our session qubit. The session qubit is the place where all the logic lies, okay? and then we go from here to the home page. So I am assuming you have the knowledge of basic using of the Qubit or block, because I already have taught them in my in the YouTube channel. You can check out the link from the video description to understand how to work with a block or Qubit, the state management solution, of course. So in the home page, what we have, the background, calling we are the background in the stack to fill all the area of the application. Simple loading the image, the welcome text, welcome to Project ASTRA EXP experimental Flutter, and then the get started button. Whenever that get started button is tapped, we are going to the session page, and then we are providing the session qubit again. So why we are providing the session qubit again is we don't have any routing setup for now, so wherever we are accessing a session qubit, we have to provide it in a separate page also. So that's it. Secondly, we have specific widgets, blur clipper, there where I use the get clip and other methods to build some minimal UI for my project Astra. I copied that from the real project Astra, but most of the functionalities are not working that is working in the real project Astra, but the minimal functionality like pointing camera to a specific object and asking question about that, this is working. And then we have the gradient text, loading widget, and then voice visualizer. Voice visualizer is basically taking the action on the amplitude that we are receiving from our voice port or our microphone. We are simply animating these 3 pills that will be displayed at the bottom right corner of our application. That's it. In the utils, we have the convert camera to image JPEG. So this method is very important here. Obviously you have to do this conversion on backend, but for demo purposes currently I did it on frontend, but it's more efficient on backend, I would say. So on frontend, what happens in here actually is taking the camera image that is coming from stream and converting it to some compressed image, because we cannot send a raw image to backend because its size is very high, so we have to compress this obviously. So you'll come to this later step by step while coming from the session qubit. So session qubit is the main place that we have to go through. So to understand this front end, you have to understand 3 core things in Flutter, so that understanding this qubit is not going to be a big deal for you. So first of all, that is WebSocket in Flutter, recording and audio playback in Flutter, and then the camera package. That's all. You must have some knowledge about the WebSocket in Flutter and how we are recording, how we are playing back a specific audio, not from a specific source like we have a path or we have that audio stored in some storage. We have to play it from stream that is received from the WebSocket. So that is the core difference. You have to understand this. And then we have the camera package. So from the camera package, we will be streaming images periodically after 1 second to the backend. So you have to understand these things. So understanding the session qubit is going to be very easy for you, believe me. So coming back to the session qubit, we have the Flutter voice engine. Now here comes the important part that I have to tell you what is Flutter voice engine. So basically this is a plugin that I wrote myself. So I had a requirement of create a voice bot. You can chat with that voice bot in real time, and also you will be able to play some background music while having a chat or having conversation with that voice bot. So I had a challenge. I searched for the different project, not the projects, really I'm saying the projects. I searched for different packages in Flutter, like Flutter Sound, SoundStream, but none of them was compatible, or like the ones that I got satisfied with it, I can use that specific package to meet my requirements. So I had no choice. I wrote my own plugin, Flutter voice engine, that is not also allowing us to play background music along with real-time chatting with a voice bot. It also provides us of only one time setting up the configuration, and just from single methods like play audio chunk, it start playing from the stream that we will be receiving from the backend. So it is simplifying very much that process, that is very complicated, I would say, as per my research. In the other packages that I have used, especially the Flutter sound package, that is more mature and can do that specific voice botting task. But the Flutter voice engine, I would say, is very simple because I wrote it specifically for building voice bots, and then this requirement that I had, playing background music along with in real time chatting with a voice bot. So that was the very important thing that I want to tell you. I will be soon publishing this Flutter voice engine so that you can also use that. I will be properly mentioning the guides that how you can use that, or you can also take it from here. I will be publishing this Project ASTRA Flutter application publicly so that you can also learn how I have used this package. Okay, we have the IO WebSocket channel for WebSocket connecting with the URL that we have, and the camera controller, and the list of camera description to have different cameras, 1, 2, or 3, depends on the device that we run our application in. A latest camera image that we will be storing in here to provide it to the model. Okay, initializing the voice engine subscription. So this is a subscription basically which will be listening data from microphone so that we can stream this data to the backend. That is what this subscription will be doing. Any timer for image send timer, we will set it for every 1 second. We will be sending an image to the backend. And about these 3 variables is initialize, is WebSocket open, is camera initialized. Just for ensuring a camera is initialized, WebSocket is open, and is camera is initialized. And the controller in here, because you'll be accessing the camera, is initialized or all the methods directly in the qubit, and we'll only be using or binding some specific work with in our session page here. Okay, so we have the camera controller in place. Now in the close method, what we are doing, that is the override directly provided by the qubit that we are extending our session qubit with. So it is disposing everything that we have currently. So the voice engine provides shutdown all to release all the resources, stop stream image from the camera controller, dispose it, and set to false, close the WebSocket and everything. So what happens in here, when we tap a start session button that you can see from the image on the screen, when you tap the start session in here, we are requesting the microphone and the camera. And one more thing that I will tell you specifically about development, if you are doing with the iOS, you have to, in the pod file, set up the permission camera 1 or permission microphone 1 so that it will correctly request the permissions, otherwise it won't. And in the Android, you have to, in the app source main XML, you have to configure for the record and camera. So these permissions are required in here. Secondly, after this already initialized, we are attempting to reconnect as the sprint suggests, as the sprint tells us. So if it's not open, we are calling the connect WebSocket. And then simply setting the is session started true to take the decision now the session has been started, and then we have to start our streaming and everything. First of all, we are initializing the voice engine. So this is the part that I told you about, only one time initializing the config, and then it is taking care of everything. We have to just call start recording, stop recording, play from audio chunk. Everything is taken care of internally by my plugin that I wrote, and you just have to configure only once, that's it. So if this condition was not true, we will come to the try block. We will initialize the voice engine. So this is basically doing if the voice engine is already initialized, so don't initialize it again. If it's not initialized, so we'll go for init voice engine. So we will simply go to here. In this method, if we are initializing it, we are setting the sample rate, the channels, the bit depth, buffer size, and enabling the AEC. AEC is the very important thing also that you need to understand. AEC basically stands for acoustic echo cancellation, and it means that whenever bot is speaking and the audio is coming from microphone, that audio is not considered as the user voice so that the bot is not responding to itself. So without this AEC enabled, what the bot will by default do is whenever it's speaking like hello, it will respond to itself like hi, how are you? Instead of like waiting for a real user to tell something. So this AEC is enabled to true, and that's very important for these scenarios creating voice bots. And these are the configurations. Sample rate every 1 second it records 16,000 samples, and a normal human voice sample rate in hertz is 8,000. But for more clear voice, we are doing 16,000, and that is efficient with creating the voice bots one channel. And the bit depth is basically the 65,000 or something possibilities to make the voice more clear. If it's 8 depth, so you will have some hiss noise in the background, but when it's 16, so there are 65,300 and something possibilities of measuring the voice and then making it clear. And its buffer size is basically configured from here also. That is the buffer bucket. Like we are recording from microphone, whenever this bucket is filled, it is sending this chunk to front end side. So this is basically based on the hardware level. You can learn more about the audio signaling, digital analog signals more in depth by asking ChatGPT or reading some article on that audio and hardwares. Anyways, next after this we are doing the session config. Session config plan record spoken audio, default speaker, allow Bluetooth, add 2DP, and mix with others. This is basically only required for iOS for voice bots, and this is the correct configuration for building a voice bot. And then we are calling the initialize method, and our voice engine is successfully initialized, and we don't need anything else. We just have to call the method start or stop recording or listening to that stream that we will be receiving, and that's it, providing it to the backend. And we are doing that like this. You will learn more about it when we explore other methods. So we came to this method from the start session, stop session here. Okay, so once this init voice engine is initialized, we are setting is initialized to true, calling the connect to WebSocket, and setting the set is session is started to true, camera is active false, and stream are still false, because these will be done once we are successfully connected with the backend server. Okay, so whenever connect to WebSocket is called, it is taking the WSS URL that we just explored in our app constant, and then setting the WebSocket to open. So this connect method is only required to connect with the WebSocket. Next, we are listening to that WebSocket what messages that were in our backend from receive from Gemini, whatever we are sending from there, like interrupted or turn completed or everything, all the methods will come and handled in the handle WebSocket method. So I have checked two conditions here. If message is string, so that means it's a JSON, so we have to decode that. Otherwise, if it's not string, so it's obvious it will be bytes, so we are receiving it as uint8 list, and then we'll be providing it from our voice engine to play audio chunk. That is all required for playing from a stream data, receive that in chunks. So this is all required from the plugin I wrote. So you have to do play audio chunk, it will play it for you without requiring anything else, because we have configured everything beforehand. And this compute RMS amplitude is just for managing the amplitude, these three pills that I mentioned at the bottom right corner. So whenever it's JSON, we decode it, we extract the type, and then instantiating connection. So whenever we have this instantiating connection, we set the is connecting to true, and based on that we will update the UI, like loading we are connecting or instantiating the connection with the Gemini Live API, or the session is starting. Once it's successfully connected, from backend we are doing the successfully connected is sent from here whenever this connection is successful. So we will receive it in here, and then we are starting recording, initializing the camera. So in start recording, if I tell you here, not tell you but show you in here, it is checking for if voice engines was not initialized, then initialize it. But we have done also this in the start session. So first of all, we are canceling that stream that we just saw, that variable that we have created, and then we are assigning it to the audio chunk stream that we will be receiving whenever we speak through microphone. So this voice engine is when we call the start recording, it will send the data in the send audio chunk stream, and once we receive this data, we will check if the WebSocket was not equal to null, was open, and recording was true. We will send this sync to add this byte audio to the backend. So we are syncing this byte to a WebSocket, and that will be received in here. These bytes are received and sent to Gemini Live API. And once we receive that, here in the data, we are sending it to front-end side and going for playing them directly, as we have saw in the handle WebSocket method in here. Play audio chunk. So these are the bytes data that we are receiving from here, from Gemini. So we were in the start recording method. So whenever start recording is called, it start listening to that stream, saving data into that stream, like subscribing to that stream subscription. So we have started the recording, and then we are initializing the camera. In initialize camera, we are simply setting the initializing to true, error null, or this error is false. If the camera was not equal to null and already initialized, we are simply doing camera already initialized, reusing. And then what is happening is here, if it was not the case, we are doing cameras, accessing the cameras, and then handling this camera is in here to assign it to this back camera. Or if it was null, then we are using the first camera, which will obviously be the front camera. And there we are deciding the image format. So the image format basically is that raw image format that we will be receiving whenever we start the stream from the camera. So we are initializing the desired format. For iOS, this BGRA triple or 4x8 is more stable on iOS, and is Android UV420. So this is more stable on Android. So we are deciding that here. Next, we are initializing the camera with the medium resolution, because we are not sending a very high-end images to the backend, obviously. And then once this camera initialize is called, our camera has been initialized, and then we are starting the image stream. To every time store this latest image that is received from the start stream in the latest camera image that we just saw, that variable. And then we are setting the stats for camera is active, show camera preview, is streaming images, and is initializing camera false, since the initializing has been completed. And then start image send timer. This is the important method, and this is where we are streaming the images from camera to the backend server. So as we have seen, we also learned in the recording, we are sending the bytes to the backend, and then we are receiving it, and in the whenever we receive the uint8 list, we simply play them. And this is the place we are sending the every 1000 millisecond or 1 second, we are sending the compressed image to the backend, so that it takes a decision on that whenever we ask question along with sending that specific image. So next we have this compute method that is taking care of the very important step, convert camera image to JPEG. So whatever that desired format that we have decided for iOS, that is BGRA 4x8, and then UV420 for Android. So from that desired format, that raw format, to a compressed image, we are doing that in the background isolate in order to not block the main UI thread. So this compute method doing that, running that task into background, running it in a separate isolate, and it will store the result in the latest camera image. Okay, now we have the JPEG bytes from this compute method. if we are checking if the JPEG bytes was not equal to null, we are simply encoding them in the base64, and then we are preparing this payload. As you can see, as you have seen, here image input, that is the type of image input, and the image data is the base64 encoded data that we are sending, and this is the MIME type of image JPEG compressed. Okay, once we have this prepared, we are sending sync add the JSON encode data in the that image, send that JSON we have prepared, and that's it. So whenever we start session, communication is instantiated, and then we first start the recording, start sending the audio chunks, and along with that we start the init camera method, and this start image, and this call the start image send timer. Every 1 second we are compressing that image and sending them live in this WebSocket directly to the backend, so that we can talk to the bot and take a decision based on that. So we were here, start image timer in the init camera. So we were again in the successfully connected method. Init camera was done, and there is an error. We do stop all the streams. Stopping all the streams and setting everything to false because an error has been occurred. So next in here, we have when turn is completed, we are stopping the audio playback and simply setting the voice is bot speaking to false, and same goes for is interrupted. That I explained how the voice activity detection in the Gemini Live API is taking care of everything in the backend. And lastly, I have explained this thing about playing the audio using this play audio chunk method. Next, we have the remaining methods in here of stop recording. So whenever we are doing stop recording, we are simply canceling the stream, setting it to null, and call the stop recording, and that's it. Only sending the sync method to audio stream in, so that the backend also understand we are now stopping recording, and you don't have to send any more chunks with this send method. And next is the calculation of computing the RMS amplitude. And in the session page, this is a basic UI calculation for the screen that you can see currently on the screen. For building such kind of UI, I have done some horizontal padding and vertical padding calculation, border radius, and then calling the start session in the init state, listening to that stream, listening to that session qubit, the consumer. In the listener, we are checking if there was an error, simply show that in the snack bar. And then whenever in the builder method, we have the qubit accessing the camera controller that we have initialized in the qubit directly. We are not doing anything in here in the stateful widget. Everything is done in the qubit. Whenever camera is initializing, we are showing the loading widget, and in the stat we are checking this condition: if camera preview was true, camera was not equal to null, camera value was initialized, we are building the camera preview. Otherwise, we are displaying some circular progress indicator. And then this is the backdrop filter for building some good UI for our Project ASTRA clone Flutter. This is the switch camera method, and this is the build top layer, and this is the build bottom layer for simply ending the session, and that's it. So we understood everything, understanding the difference between legacy voice bot and human-like voice bot, and we learned about Project ASTRA, and then we have gone through the backend code, and then we also understood the front-end code, and now it's time to run this application Project ASTRA along with our backend, so that to test how this application works. So to run that backend on a local server, you have to ensure your Wi-Fi in your phone and your laptop is on the same internet connection. You have to run this command uvicorn source man app reload host on 0.0.0.0 and the port 8000. Once you have this command, you can simply hit enter. It will run the application. Now once our backend is running, we have to go to our Android Studio and connect our real device to run the application in there. So after the application runs successfully, it will simply land us on this simple page that you can see currently on the screen. It is simply showing welcome to Project Astra, the minimal page that I have built for my Project Astra clone in Flutter. So as I tap this get started button, it will start the live session with a voice bot of Gemini Live API using the backend that is running locally on our local network, and that same network is connected in our device. So now I will go ahead and tap the get started to test this voice bot. So I am going to get started. Hello, can you hear me?
Yes, I can hear you. How may I help you today?
Can you tell me what is currently on my camera?
Sure, I can help you with that. Your camera is currently showing a laptop with code on the screen. The laptop is open and a hand is visible near the trackpad. In the background, there are 2 black couches and a tripod.
Yes, that is perfect. So now what are you seeing?
I am seeing a room with white walls and a blue ceiling. There's a eTechViral sign on the wall. In the center, there's a black camera on a tripod, positioned in front of a black 2-seater couch. To the left, there's a coffee table with a glass top and a purple cup. On the right, there's a person sitting in a chair, but only their legs and feet are visible. There are also several green plants in the room. In the foreground, a laptop is open, displaying lines of code.
Yes, that is perfect. Now secondly, can you tell me...
Great, is there anything else I can help you with?
Yes, can you tell me what is currently on my screen? Hello, can you hear me?
Yes, I can hear you. How may I help you today?
Okay, what are you seeing currently?
I am currently seeing a laptop displaying a Google image search for birds. The screen shows various bird images, with a prominent image of a bluebird on a wooden post.
Okay.
The laptop's...
Okay, that's perfect. That's perfect.
Is there any...
Thank you so much.
Is there... You're welcome. Is there anything else I can assist you with today?
So that was the clone of Project Astra and its capabilities that we have used from the Gemini Live API. And as more capabilities comes to the Project Astra, the real Project Astra that we have just saw initially in the starting of this video, as more capabilities come from this Project Astra to the Gemini Live API, we will be able to do more amazing things with this Gemini Live API, believe me. So that was all. Now if you have any question about this Project Astra clone, the backend code, the frontend code, you can ask me in the comment section. I will simply push the both backend and frontend code both on the GitHub. So if you want the source code, you can simply go ahead and clone that from here and use it as per your project requirement. And if you want to enhance it more, so you can do it as per your requirements. It's upon you. So other than this, if you are the person struggling with learning Flutter, I have created an entire playlist on this named Flutter and Firebase Development Bootcamp, where I taught from why and what is Flutter to creating a complete application with clean architecture and literally everything that you need to know to become an in-demand Flutter developer. So you can check that out from the link in the video description. And if you enjoyed the video, subscribe to eTechViral and I will see you in the next video. Thank you so much.